Here we go. Cool. Enrique, want to share what you talked about?
Yeah, so we talked about using the terminal and comparing it with like running like Ruby and then the file versus running pry, right? My partner, Daniel, he was just like, I just learned about pry, so I'm not sure what the drawbacks are, but he was really clear that like running the file through Ruby was like time consuming and just kind of like was really hard to kind of play to figure out what could work eventually. And so like he then imagined pry being like an awesome play, which it is, right, to like play. And then I went in, I was just like, yeah, but I've been using pry for the last 6 weeks, right? And the kind of drawbacks of that is like you could end up playing towards the wrong solution, right? And so like there's still this like missing piece of like what problem are you actually trying to solve? So even though it might appear quicker, like it's still lacking like an anchor towards like what are you trying to actually create and solve here.
Yeah, I think that's fantastic. Anyone else have any other thoughts in particular? It is okay if you do not.
Yeah, I want to add to that.
Yeah, go right ahead.
Just kind of without having like the formalities of like testing, you are kind of trying to find out like where did something go wrong, or if how do you solve that one problem if it's all kind of tacked onto it, where like a test is a very isolated thing. You can kind of chunk it up so that it's easier to access like smaller chunks of like the bigger thing that you're doing.
Great, the fantastic points, both. Today we're going to mainly be talking about the mechanics of testing, as in like how we test. You're going to have a class tomorrow that goes a little more into philosophy or why, but I do want to take a little bit to kind of stress just how important testing is. This is a topic I've been thinking about a lot, spurred on by a conversation with another student, and I think that like it makes me think about a couple of quotes. I saw a quote recently online. It was attributed to the inventor of C++, that untested software is broken software. Right? If you are not able to definitively say like this thing, I know this works, fundamentally it doesn't work. And this other more humorous quote I saw was like, if you don't like testing your software, your customer's going to like it even less, which I think are both very fair points. And so we're going to talk about today and kind of show you some of the etiquette and like some kind of conventions that go into how we write tests and how we kind of create our tests. First, number one is that tests live in their own directory, right? They live in a directory called test. Code lives in a lib directory. And following that, tests should reflect what they're testing with. So let's say we have a pizza class because we love pizza. For a pizza class, let's say the pizza class is in a pizza RB, then the test for this class would be pizza test.rb. This is kind of like we talked about this a little bit in yesterday's class. Like we try to follow the principle of least surprise. If I have a pizza.rb file, we want it to expect like, hey, in this pizza.rb file, I'm going to find a pizza class. And when I go to a pizza test file, I expect that it's going to be the tests involved for the pizza class, which I can then find into pizza.rb. Like the idea here is that we want to be, the term for this is being very opinionated. When we do things in a certain way and we follow these rules and guidelines a certain way every single time, we no longer have to think about like, oh, what's where something. We just know like, hey, this is where things are. The test files go in the test directory, the code goes in the lib directory, and that just works. In our tests, we're gonna have to require the original class file. Because one file needs to know the other, and we generally want to run the test files from the root of our project directory, and running the test file will call all the code we need. Any questions about those technical points so far, Sean?
Yeah, I'm curious. For the test, we always have to like state that it requires the pizza file, for instance.
Yeah.
Why is it never the case that the pizza file needs to write to the test file because we're passing the information back and forth?
What do you mean by write? Can you say more about that?
Like how we create a class pizza and it has pepperoni. I guess I just need to think about it a little bit more.
Okay.
Because to me, the understanding of the two files, it's not just one way.
Mm-hmm.
The test file.
Okay. Let me kind of expound on that thought, right? But please can finish what you were saying.
It was just that the test, pizza test seems to go into the pizza file, and it seems that the pizza file also, you know, returns information back to the pizza test. So just curious, why is the reader necessary for the pizza file, but a writer or anything like that it's not necessary for the test?
Okay. So I think that we have a small misunderstanding about like what's happening when we run the test. When we run the tests, what that required is like, hey, go grab me whatever's in the pizza file and bring it into here, and I'm going to run here. Because the thing is that we don't do it the other way around, because when we run our tests, we're not actually running our code. We are running the test files. The test files then grabs what it needs and runs what it needs. So like that's why the test file requires the pizza file or the code file, whatever, in this case pizza, and not the other way around. And the two kind of live separately. Like when you are running your code and you decide to create like a pizzeria simulator or whatever, we are never running the tests. The tests are in that kind of particular instance used to verify the functionality. We are not running the tests like along with the code in the process.
Oh, okay, thank you. I think it's simply overlooking the aspect of the required file, and that's giving it everything that it needs. So,
yeah, require. I think the term require can be conflated a little bit here. What require means is we're not saying like, hey, this file is a requisite. We're saying require is essentially like, hey, go load this. I think that like because the word is require, it may cause some confusion there. Cool, John. You are muted. Nope, there you go.
Yeah. So just for clarification purposes, in what we were doing before in the previous class, we did the person.rb and then the runner.rb. That's separate from the test file.
Yes. Your code goes in lib file, and those are just files to run the actual application. Your test files are code that you write to verify, for right now, verify the functionality of the code that you've written.
So the test file tests one. Can you use it to test both?
Yes. Yeah. Like, we're going to start off with testing very small things, but then we'll get to the point where we test bigger and bigger things. We're going to start off with small steps first to kind of show you, like I said, this is we'll get into more than that tomorrow, but today we're going to just kind of like work on like the mechanics and just like the syntax of testing.
Yeah. Compounding on that first initial kind of warm-up question you gave us, you know, we're kind of getting into the territory of new files are coming out, whereas before when I was struggling through it, it was just puts and prints everything.
Yeah. Oh yeah.
Whereas now things are coming, you know, new files are being created. So I was just kind of wondering what. Okay.
Yeah. Some people use put statements, print statements to like print things out the screen to make sure things are working there. And that's a process called puts driven development, which is not great because it requires a human to kind of look at things. And you know, like I know a lot of times, I'm sure you've all had this experience when you're working on some code and suddenly like this word you're working on no longer has any meanings whatsoever, and it's very easy for us to gloss over it. What we're doing is teaching you the way to automate your tests so that things can be just done more efficiently, right? I think that like the whole point of programming is to automate repetitive work.
Okay. Cool. Just my specialty is doing not good things. So, yeah.
I mean, that's my life in a nutshell. So, welcome to the club.
All right. Thank you.
No problem. So let me unshare this. Wait, nope. And I love it whenever I do anything in Zoom, it resets the user interface. So I have to move everything all over again.
There's actually a way to fix that.
I've looked for it, but like the thing is, it gets a little trickier when you're using two monitors. All right, so you see my screen and my terminal down below?
Yes.
All right, got some thumbs up. Cool. So what we need to do is that the first thing we should do is we need to install our testing framework. And in Module 1, we're going to be teaching you how to test using Minitest. And it's a testing framework using a lot of the homework stuff. And we make sure it's on our computer by doing a gem install Minitest. And it figured like, hey, I'm going to grab everything. That's great. And what we're going to do, a couple things about Minitest is that in your test, you're going to need to require Minitest, right? That pretty much says like, the idea here is that Minitest is not code that's included when you're just Ruby. We need to tell it to bring it in. Much like we're going to require a pizza file, we need to require Minitest, so we're going to do that. And you need to require Minitest auto run. And there's some conventions. Let me open up a file here and make it bigger. Is this big enough? Anyone disagree? Great. A couple of things to note is like when we, there are some hinkies to Minitest and conventions that we need to stick to. First is that the test class name, that has to be, it's going to be class and it's going to be name of class test. It has to end with that word test. That's just showing how we do things. It's how we're able to communicate like, hey, so you know, this is a test. So like in our previous example, we were testing a pizza test. So it would be pizza test. And that's how we would kind of build that. And we also need to inherit from mini class test. So let me do this. Let's just pretend we're writing a class for the pizza class. Class pizza test. And things that we talked previously that we need to bring in the code. So we're going to require Minitest auto run. And that is the code that will make you bring in the testing framework and give you all access to all the methods that we have not written explicitly. And the things in our test is that we also need to inherit from Minitest test. So we need to add in a Minitest test. Test is essentially a module or a bit of code, a block of code inside Minitest. And what we're doing here is like, hey, in this class, I want to use the code that's in Minitest test. And I'm going to put that end right there. After that, when we want to test things, each individual method is going to be a single test. So inside your methods. And the thing here is that like method, and we want to say, let's just call test something right now. And this is going to be the name test. And I want you to note that your test methods need to start with test underscore. If it does not, your software will not run. It'll just kind of ignore it. It's like, oh, this doesn't start with test. I'm not going to run it. It's just going to kind of ignore it. And inside this test method are the things that you're going to test. And I think the biggest thing that I've noted, like when you're using Minitest, is what Minitest gives you is that it gives you assertions. And assertions are this method that compares two things. And so one of the basic ones we're going to use is assert equal. And it's going to take expected, two arguments, we're going to say for argument's sake, and actual here. And what happens is that when we get, the code is going to run, this test is going to run, whatever code we have up here is going to run, and it's going to hit this assertion, this assert equal method here. And in this assert equal method, it's going to compare this, expected is like what we want, and actual is what is coming from the code. If these two match for assert equal, that's why it's called assert equal, it will return a positive, and I'm sorry, not a positive. It will return that. It will say like, hey, this test passes, everything is fine, everything's great. If this is a mismatch, it will fail. And like, this is the kind of basic structure of how we want to set up a test. We're going to go into detail and actually show you some tests in a second. But right now, do you have are there any questions from anyone about what we're doing? About like the syntax or what pieces of the syntax mean?
What is minitest /pride for?
Minitest pride. So what we can do is that if we want to add this, when we run the test, it'll make it pretty with colors. This is totally optional. Most people put in there because it feels good to have green tests, and feels, it's kind of cool when you see, when you first start, all your tests will be red because they're failing, and slowly as you write code and you work on your code, they'll turn green. That's very satisfying to some people, but it is optional. It is up to you. There are other ones. There's like, there's a Minitest Nyan Cat, which has the cat with the rainbow that people like to do. Some people do that.
What is that one? Minitest what?
Nyan Cat. I think it's Nyan Cat. I'm not sure what the gem is, but there are other ways you can customize the output. Most people just use pride and leave it at that.
I have a question about the part after you define the pizza test class. So in that Minitest, yeah. So Minitest : test. So can you go over that again?
Yeah. So let me kind of walk through this step by step. The first thing here is we're requiring Minitest auto run. This says that I want to load up the auto run part in the Minitest gem that you've seen me gem installed down below. Cool. That is essentially in our code. What this does is like, hey, I want this pizza test class to inherit from Minitest and the test module inside of Minitest. We're going to go into inheritance a bit more into detail a little later on, but it's saying like, hey, I want this class to have access to these methods and access to the assertion methods down below. Because we're using this assert equal, but have you ever seen assert equal before? Have we defined assert equal anywhere? This is one technique in which that we are going to bring in code from a third party, in this case, the Minitest gem, and use that in our code. It's like what I talked about yesterday. We want to leverage code that's written already, and things, technology that's been written already, right? Like the auto manufacturers, they do not reinvent the wheel every single time they decide to build a new car, right? They just pull a wheel off another car usually. Saw a hand. John?
Yeah, so just going off of what Angela asked, so I get the Minitest part and I get the inheritance part. Just that last part, the test, what is that last one referring to?
It is a module inside Minitest called test.
Okay, thank you.
It's like a subdivision in simplest terms, a subdivision inside Minitest. Cool. All right.
So Minitest is a gem, and
yes.
we can import parts of a gem using that notation, which would be modules in this case. Yeah,
and we're going to go into greater detail about how you can do it yourself, create your own modules, and import them into things to kind of reuse code.
Cool.
Right. Cool. So what we're going to do is that we are going to write a test. Right. We're going to test that a student exists. A student object has a name and it has cookies. And that a cookies is an array that holds kinds of cookies that are strings. I'm going to paste an image of the interaction pattern in your Slack channel. Okay, there it is. And that's how I kind of want this class to work. And we're going to write some tests based on this interaction pattern above. So I'm in my testing folder. I'm in a project folder called testing. I'm going to make a lib directory. I'm going to make a test directory. And I'm going to make in my test directory a student test.rp file. Cool. And we have this test file. And first I'm going to do is I'm going to require test run. And do class student test, and it's got to inherit from test test. Nope. Autocomplete is the worst. Cool. And what I like to do is that when I'm running my tests, I kind of like to make notes for myself using comments about what I need to test. If there's a bunch of things, I want to test it exists, test it has a name, test it has cookies, test it can add cookies. Sounds reasonable. So we're going to tackle, I'm just going to tackle them in order. Def test it exists. This is generally the standard first test. We want to test that an object exists. So we can do student equals student.new Alice. Right, and I already showed you a little bit the assert equal method that checks the two. This is another assertion we have access to. Assert instance of student. And what this does is that it's going to see if student, lowercase s student, which is an instance of this student object here, if that is a student object. If it is, it'll pass. If it doesn't, it'll fail and it'll yell at us. Questions about that, what I've written there?
So the assert instance of, does it can it only refer to like a class?
What do you mean? Yeah, assert instance of is to check the class of a thing.
Okay, so like you could also test assert instance of an array to see if something was an array.
Mm-hmm. Yeah, and essentially the thing is that like I think that assert equal is kind of a catch-all. Is that you can do two things. So like assert equal checks to see if two things are equal. So technically I could do this. Expected is on the left. Right? Essentially like these two are the same. But I think that like when we do something like this using the more narrow assertion, we're being a little more specific, a little more explicit. But essentially these are functionally the same thing. Cool, that test worked. I'm just going to delete that because that's something I finished. And so I have this test. I'm going to I've saved it. I'm going to run the test. Ruby test student test RB. And it says uninitialized constant student test. And that says like, well, I don't know much about student, do I? Like I don't. Like this error message says I don't know anything about a student object. So what we're going to do is that we're going to go ahead and make a student object. Student.rb, check. I'm going to open this side here. And this is in the lib directory. I'm going to do class student and when I run the test again, I still get the same error. And the reason I get the same error is that, yeah, I've created myself a student RB file, but this test doesn't know anything about it. So I need to tell this test where to find it. What this is saying is like, hey, from where I'm running the dot slash, just mean from my current location, I'm running in the testing directory. I want you to go into the lib directory and then load the student file. I'm going to save that, run it again. And wrong number of arguments, given one expected 0. That's because I have no arguments here for initialize. So I'm just going to do def name. I run the test again, and it passes. And we see that's like, cool, 1 dot. This is without using Minitest Pride. If I were going to, if I need a little more color in my life, I add the Minitest Pride in here. I run this again, and you can see that I've had a fabulous run with the green dot instead of just a regular run. So I would highly recommend using this if for days that you need to absolutely, the days where you're feeling less than fabulous and you need someone to tell you, like this is what we should use. And again, it's very satisfying to start. Let me break this again. And let me show you what it looks like with Pride when it's not working. No, it just errors out. We'll get into that. We'll show you what it looks like a little later when things fail. Name. Any questions at this point about the code I've written here, the test I've written so far? Cool. All right, so the next thing we got to test. Test it has a name. Cool. Def test it has a name. So, and we're going to do assert equal student dot name, right? The idea here being that we're going to pass a name. I expect to be able, I've passed a name where I've initialized this object. Well, I'm going to expect to be able to get that back out, right? I'm going to save my file. I'm going to run my test. And we see here that I have this error message, undefined method name. And we can see here because of Pride, I have this green dot because this test passed, and a big red with an E because this test errored out. Right. And then we go and write the code for that. We can test it has cookies. Actually, this working. We do test it. Bobo. So you know, sometimes when I type, I do go silent because I have a hard time talking, thinking, and typing all at the same time. And so I need to cut one of those out. So as I'm typing, I may get a little quieter because I cannot do all three at the same time. Right, and we assert that it is an empty array because we have not added any cookies. And then we can go ahead and test it has cookies. Nope, it can add cookies. Good cookie, snickerdoodle. I'll just add 2 cookies for now. And then we can do assert equal student dot cookies. All the way around. I should have picked shorter words. Chocolate chip. Why did I pick literally the 2 longest cookie names? student.cookies. Let me resize a little bit so you can see a little better. Cool. And these tests are rather simple, and they only have like kind of like instantiating the object, and we're just asserting. As we get into a little more complex tests, I kind of like to think about this kind of pattern of testing called SEAT, right? It's the setup, execution, assertion, teardown, and the setup is kind of this line right here, right? All the lines of code that need to be executed to verify behavior. And so like right here, like if we're going to test a student, we need to instantiate a student. That's kind of like we're setting up the test. The execution is the actual running the method we're testing. For example, like this here would be the execution. We're adding cookies to it. Right, this is the code we're like that's supposed to trigger the change or the thing that we need to verify working. And we have the assertion here, which is like going to be the checking like, hey, is what I got from my code what I expected to get? And finally, there's teardown. Teardown is like sometimes we need to reset like the environment, the kind of the world space that our tests live in, and that's what teardown is. And you're not gonna do too much teardown in module 1, but just know it is a part of it. John?
Yeah, so that part, I noticed this for the card test and card test was when I first ran into the test, but I noticed it in there as well. But each time we do the test, the define test it can add cookies, the define it has cookies, the student equals student.new, that I notice is in every part. So I guess it's a two-part question. One is that the only one that has to be included in each test? For example, if I'm trying to test, let's say.
So I want to mention, so the thing is that like there are ways like you will have some repetition in your test. Like if, for example, like each of these tests, we created a new student. You can use something called you can use a setup method in order to kind of like pull that out. We're not going to go too much into that today. Personally, I don't like setup methods because I think that they get a little overly complex because you're trying to have one setup method work for everything. And that when I'm working with the test, I like to see everything in front of me, like it's right there in front of me, so I don't get kind of lost. Especially when your test files get longer and longer, you don't remember what you've done to kind of like reduce a thing. You scroll up and down, and I get lost very easily in code. But like the thing is that if you were testing a student, I think the important thing, the word I want to use here is that each test is atomic. In that is individual and has no bearing on kind of anything else in this thing. Like this, what happens in this test has no bearing or effect on what happens in this test, and what happens in this test has no effect on any other tests. So we do need to kind of reinstantiate the objects that we need, anything else that we need within every single individual test.
I was just wondering, this one's testing max 4 things, but when it becomes, like 100 things, does it become more than what it is now, I guess? Or is
tests will get more complicated as you go on. I think I would say that if your test is testing 100 things, then I think that we need to look at I think that whatever you're testing is doing a little too much. But that's a discussion for a later time.
Okay, thank you very much.
No problem. Angela?
So I had basically the same question as John when I was doing my deck class. My the lines, like the first few lines of every single test were the same thing. So I tried using the setup method, and I thought the setup method would create, instantiate the deck and the cards that I needed every time before my test, but then that wouldn't work. That it wasn't working because of the variable scope, because I was creating those variables inside the setup method. So my other test methods.
So let's put this in the parking lot. Let's put that question in the parking lot. It's not really kind of focus on what we're trying to convey here, but essentially we're going to cover scope a little bit tomorrow, and I'll talk about a little about what you need to do to get your setup method working after class.
Okay, cool.
Cool. All right. There are some little nuances to testing which I think are going to be pretty important for you. One, tests will overwrite previous tests with the same name. So each test name has to be unique if you want all your tests to run. If you only want one test to run, by all means, name it the same. But that would kind of defeat the point of testing. And like I said, each test is atomic. Like you cannot depend on tests running in order. What happens is that when you run your test, every single time you run your test file, it will generate a random number and use that random number to figure out what order tests are. So like this first time around, this test could run, this test could run, this test could run. Well, the next time we could start with this one and then this one and this one and this one. They are run in a random order to make sure that like no code ever becomes dependent on other code to run in a certain sequence. Another important point I want to make is that we also want to ensure dynamic functionality. This test, it has a name. Is this a good test? What are your feelings? Do we have feelings about this? Do you have thoughts? Sal, what do you think?
Oh.
I love calling on Sal when he's checking out.
Mike, I think you have a student volunteer. I have some opinions, but
I gotta take Sal's back because I'm always gonna have Sal's back. So I think Testa has a name is definitely like an attribute. And so it's just kind of like you can.
The big kind of picture I kind of want to make is that we want to write in our tests in a way where that you can't screw with the code and have the test still pass. And I'm not saying screw with in a malicious way, although that is a possibility. Like it could be something that is just a pure mistake. So when we see this test, right, with what you know now, we can make this work by doing something like @name equals name, and then making a adder reader name. And that should deliver this functionality, and this test should pass, right? Does anyone disagree with that statement? Or am I lying to you?
Well, each one of your tests has a different name.
Yep. Yes, it does. But let's just say like this test by itself, right? This should pass. But the thing is that like, what if we did this? If we did this test still passes, but it shouldn't, right? We want to ensure dynamicness. Is that a word? It is now. And so when we test attributes, we should also test that it can be different attributes. Like def test, it can have a different name. Lamp. Something like this is also very appropriate.
Why wouldn't you put them together? Is it bad practice to have multiple assert equals within a mini test?
No, you can certainly have more than one assertion inside a single test. I just feel that I would separate them because they are testing different ideas. We are testing separately that it can have a name and it can have a different name. There is nothing that says you can't do something like if I can only type today. Like you do this. I guess you could change, but thinking I'll probably change name. This has a dynamic name. Like you could definitely do something like this. I'm sorry, this bothers me. I need to make things consistent. Like that. That is something you can do. I don't know. I guess for me personally, like I've been doing it this way for like ever. And I know this is okay, but it just doesn't feel right because I just don't do it that way. Yeah. It's good. It's fine. Like if you do this, I'll not be upset at you, but it's just like something, it bothers me inside somehow and this is a completely irrational feeling. John?
Just to check my understanding, if at the student.rb file, if you changed the value of the instance variable to Sal, then the test, it can have a different name. LAMP would fail in this case, right?
Yep, it would fail, but this one would still pass. That's the idea.
Okay, thank you.
Does Sal have also have strong feelings about which kind of testing?
I see a head shake. Oh.
No, I don't. I think, and I think that this is like, to kind of take a little bit of a step back here, I think it's like super interesting. And Mike, I don't know, I'd be intrigued to hear your thoughts on this. Like, programming is going to be a place, you all, it's just your week one, this is so fun. I think programming is going to be a place where you find that some people have like very, very strongly held opinions. And some of those, even I think on staff, like on the instructional team, some of those I'm like, yes, there's a good reason for that. Like, absolutely, we should all be doing that. And sometimes it's like, we do it that way here so that we can write code that is consistent, so that as a team, we can step into that code and we can understand it quickly. And so I think in this case, it's something where the important question becomes, how does my team do this, and can we all agree on like the same way to do it?
Yeah, I think that like I think I mentioned to you yesterday, like when you're on a job, like maybe all this goes out the door and you just do what the rest of your team does regardless. I like, like I said before, I will try my best to tell you when I do certain things because of opinion and not for a reason. And I'd like to think that I am self-aware enough to know when I have an opinion about something and when something is objectively good. And like I think this is a point where my initial instinct is like, oh, I don't like that, but it's like an irrational, I don't like that. It's just a force of habit. I don't like that. And I think that I would challenge you all to like challenge me if I do something, like, why did you do that? Like 100%. Like, do not be afraid to ask why I do something. Like, I think it's always good for us to challenge our preconceived notions. And when I look at this now, I like it more. Now I've had a chance to ride down from that emotional gut reaction. I kind of like it more, and I may start doing things this way once I think about it a little more. Because like why don't we combine those two? It makes absolute sense to combine those two into one test instead of having it written out longer.
Mike, can I ask you this question? Like,
sure.
And we don't have to go too deep into the weeds with it, but Sal, maybe you can kind of chime in too. Because I got really comfortable writing, I guess, what I would consider kind of like long code, where you're actually including all of the variables and stuff in each test versus a setup method. But then I've also been suggested that setup methods could become useful if you're doing longer or larger projects, so that you're not having to like copy paste so much stuff. So I was just curious, like in the real world, is having a good understanding of setups beneficial, or is it really just based on the employer?
I would say both. I know it's probably not the answer you're looking for. Personally, I'm not a fan of setup methods for the reason I said. Like, I think that I like to have all of my code, all of my tests in one place, Because when you have when your setup methods get a little long, what happens, this is what I'll do. I'll look at my test like, oh, wait, there's some setup stuff in here. I'll scroll all the way up to the screen. I'll see the setup method. I'm like, cool. I'll scroll all the way back down and then completely forget exactly what I just saw. And then I'll go all the way back up again, look at it, come back down. Guess what happens? Still forget it. And like, I'll literally have to scroll, it takes me it's just a hassle to keep going up and down until I finally get something. I like to have everything right there. I think that one thing we see from students as they use setup methods is that it becomes this junk drawer of code. Things that go in the setup method should only be things that are used by every single test in that file. And like, that's drying things out. But people, what they do is they just, students will also, and people will generally copy this huge chunk of code, throw it in the setup method, and like some of it just doesn't get used. So I think that it's good to learn how to use a setup method properly. Sal, were you going to chime in?
Yeah, I think, I'm sorry, was there something else?
What?
I'm sorry, I thought somebody was asking more of that question. I think to me, the thing it highlights is that like, that this question actually highlights really is that so much of programming is about trade-offs. And so I think that like if you think about it as a trade-off, like what Mike just talked about was the advantage of having code in one place in a method that you're testing is that you can look at it and you can kind of know that it's all in one place, and it makes it a little bit easier to kind of hold it all in your head at one time. The disadvantage of that becomes that you are like repeating that code a lot, right? Your file becomes longer, you're having a lot of repetition. So you can then, and the question to me becomes like, is there a pain point at which you decide, oh, actually, I want to move this into a setup method? Or, I mean, and this is not for today and probably not for Mod 1, but like, you could abstract it away even further, right? And say, you know what, I actually want to have a class that does all of this setup that I can just call to like do setup in this test, right? But now it's like, okay, now I've decreased the number of lines that are in one method. And so what I have to think about in any one method, but I've increased the complexity of my system. And now I have to go to a whole other file to even figure out what this setup method even does, right? Or what this like setup class even does at that point. So it's this piece of, again, it's this piece of trade-offs and sort of thinking about like, what is the pain point that I'm feeling?
We're going a little late, but let's just get Leah a question, then John, and then we'll wrap this up.
Yeah, so testing seems like something where you could like go on infinitely. How do you determine like, oh, okay, I have enough tests at this point, or if this is a thing, like I've gone overboard and I just have too many?
I think that in general, we should err on the side of too many, but not too many. I think that this is just something that's going to get a feel. I think that there are, you'll start, as you get more usage, you'll start to see the patterns about where to go and how far to go. I think that like you could go to the ends of the earth in edge case testing, but I think that like, this thing called Pareto principle, where you hit like 80% of what you need in 20% of the time.
Mm-hmm.
So as long as you get like a good amount, like the basics, and of course your thresholds will change depending on what you're building. Like let's say you're building life support machine software, like I would, go to the ends of the earth, right? But like maybe for some small application that like rolls dice for me, I'd probably be a little more lenient on that.
Okay, that makes sense.
Mm-hmm.
Thank
John,
you.
then Priya.
So this test, the test that has a dynamic name, you use this to replace the test that has a name test?
Yep, and different name.
Right. So is this test taking the place of both of those?
Yes.
Okay. So you just combined,
mm-hmm.
And that's something that if we have a chance to do within our testing, that's fine.
I mean, you can do whatever you want. This is just one implementation of it.
Okay. All right. Thank you.
Yep. Bria?
I was just curious if you would run it in your terminal.
Right now?
Test, yeah.
I think it would. Let me change this back to the way it was. think that we would have some failing tests because, we haven't done this, we haven't done this. If we scroll up, we see that we got 2 passing tests and 2 failing tests, 2 erroring out tests.
Okay. So that's what I thought that it would just be the cookies that are supposed to have failures, but for some reason I'm getting failures with my names. And so I'm just like, I don't know what's going wrong with mine. Okay, I'll figure it out. Thank you.
Yep. Feel free, if you have problems, feel free to post in the parking lot thread. Cool. That's it. We have a CFU for you. If you could fill it out like sometime later today with some questions to review, both what we've covered here today and some things that, from the questions asked that we feel are important for you to get from it. Have that done by the end of the day. I also highly recommend that you work through this testing exercise on your own. I've posted the link to the lesson plan in Slack. We're all set. Have good lunch, and we'll see you this afternoon. Goodbye.